Today's session is mainly about how we are applying statistics and ML in real life. So we have been bombarded by a lot of things in our recent days about data, the big data, and ML and AI and all these. But actually, those are very pretty jargon words which are generally used. But when you see it very basically, we have been using statistics for a very long time, and statistics is not something very new to this world. So that is why I thought, like, how are we applying statistics? Like you, me, everyone is using it on a day-to-day basis, but we are not knowing that these are all the base of statistics. And once we came to know that these are the basics of the statistics, we will be coming up and appreciating it. So that is what the main focus of this webinar. So first basic question, what comes to our mind? What is statistics is all about? Like, is it some alien word or something? Like we always seen statistics from a very far distance. So we know all arithmetic calculations, like all the multiplications, division and all. And we are also, even we don't say we are that far from algebra or something, but always statistics, we are not sure, like, why something is happening over there. Okay, there is some gray cloud over there which is called statistics, and something happens, and some people are experts in that and actually bring out some real insights. But it's not just things. So if you simply see what is statistics, it's simple as the slide speaks. It allows us to make sense of and interpret the data. That's all. It's just a simple thing that if you see cricket match, you will see what the bowler comes and bowls, he hits it with a bat. That's all. So you see what, and you make sense of, okay, this batsman is a good batsman or a bad batsman or something. So like that only is statistics. So it's in plain. You can easily see and interpret it. So that is the basic core of the statistic. And there are few parts. So basically, if you drill down statistics, you can see a few kinds of steps which every statistician would try to take. Is first, he would try to collect the data as much. So we are in a very data-driven world, and we say that data is the new oil and all. So why people are so much into data is because data gives us very nice interpretation and nice kind of results, so which we are not generally able to see in our real life or real life. So whatever we try to interpret is about what is the knowledge we have gained till now, and using that information only we usually interpret our data. So whatever we do as interpretation with whatever knowledge that we have is also a kind of statistic. So that is why I'm saying that you and statistics are not so far. You are actually very close to statistics, but the knowledge on that we are using statistics on a day-to-day life, that is the missing piece that we are actually not doing it. And that is what something this session is also going to help you to realize, that these are the things that, oh, I've been using this every day, and maybe I'm not aware of this yet. So that is, so as you can see, the various pieces like collection, organization, and analysis of data, and how you interpret the data, and the way which data is also presented, that is also a piece of statistics that you can see. And specifically, statistical data consists of these three pieces. So you would have a data collection phase, and then you have something called the population and sampling. So basically, if you want to do some research or something, what you would do, you would take a sample of the population. Say, if you want to have a new drug which is coming out. So in recent days, we all heard about this COVID vaccine, which is now trending. So in all these, we can see like we select, we have the entire global population now requiring this COVID vaccine. But what we do is we take a specific segments of people, and then the scientists are all the pharmaceutical experts. What these scientists are doing, they are just sampling on a piece of the population. So they will start with a simple population like 100 people. Then they will go around and give the vaccine to 1,000 people, see the results. So the experimentation and sampling, that all these are statistics. So these are not nothing very new to us. So every time we do something, we get marks, or every time we get a pay. Every time we would like to know what is the average. This is a very crucial question everybody has. So even if your height or if your weight, based on your weight, you would always seem to be curious about this question, whether you are above the average or below the average. Every time, usually in your performance assessment, so many of you be working in a corporate, or the income that you earn every month that you get, or the marks that you get out of every subject, you are mostly crucial about what is the average, what is the class average, and have I done better than the class average, or I may still have some scope of improvement, so that I can reach at least the average first, and then go about doing it. So this is not just only in the marks or something, even in your height, or even in your weight, in your day-to-day activities, like even the amount that you spend for expense, like you would know what an average household expense would be. It will be like 20K or 30K something, and am I earning more than the average expense that I am generally doing? So all these are the day-to-day questions that we generally do, and but it is all statistics. Like we all do statistics on a day-to-day basis. So that is one thing, and we must have seen this bell curve in our syllabuses. Like we used to draw these simple bell curves in our notebooks, and they would say something like around the center, it is equally distributed, and you can see 50% of the population over here and 50% of the population over there, and it is a symmetrical about the mean or median, so whatever you call it. So, but the one intuitive thing about this is it is actually happening in almost all the natural processes that we have. I can give you some example about the height and weight. So the height and weight distribution, when you take about a given population or a given country or a state, you can, when you plot all of these, you can see a lot of people falling into the center region, and whoever is present towards the right extreme or towards the left extreme are just the outliers. So or else you call the extreme person. So there could be very less number of people more than 7 feet height or 6.5 feet height, or there could be very less number of people less than 4.5 feet height or 4 feet height. But you can see most of the people in the population would be around 5 to 6 feet, between 5 to 6 feet, and that is what this bell curve actually tells us. So, and I will give you a real example on how we get paid. And so every year we get these performance assessment, and we get the increments every year. So the increments, as you can see, a large number of people would always fall in the center. Around 70% of the increments that we get in any of these payoffs. So a very less number of percentage would get a large rise. Say generally we get around 10% of rise, but there are few people who are doing exceptionally well, and they would be only getting a large amount of the share of the pie. So they would be getting around 15% or 17%. But the moderate raises, that whatever we get is actually matched with the rate of inflation only. So if a rate of inflation, say for a year, is around 8%, and if you get around 9%, you are just 1% of inflation. So don't feel happy that my employer gave me 9% or 10% inflation, but the actual rate that you have to see is the inflation rate what your country is going on. So if your country is going on like say a 15% inflation on year rate, then you are getting a 10% salary hike. That means the employer is not giving you the right amount. Because you are actually working 5% less for your salary which you have been working in the previous year. So it is not actually a raise; it is actually a diminishing returns for you. So as you see, they are very closely related fields, but there is a one principal difference between stats and ML. Stats usually draws inferences from the population data, and based upon a sample, as I saw, the COVID-19 vaccine, whichever is now tested on that, once the vaccine is tested, they would derive results from that, and then see the inferences. Okay, these things are happening good with the human body, these things are happening bad with the human body, whether these are acceptable or not acceptable, whether these are within the threshold limits or above threshold limits. So all these threshold limits come again to the average, whether the average intake for this kind of vaccine is good for a human body or bad for a human body, whether it is above the average or below the average. So all of these draws into statistic. But machine learning is most on the predictive patterns. So like what happens next. So that is the most crucial thing which happened today's world. Like what happens next? So I am going to invest 100 rupees. So what will happen? Whether I would get 110 rupees as a return, whether I will get 120 rupees as a return. What is the past returns that this stock, this investment has given us? So we would go about having 5 years data about, okay, in a 5-year average on an annual revenue is around 8% or 9% return. So going forward also, if all of these conditions are met, you would get a 9% or 9.5% return. So that is what machine learning would try to answer here. So it gives you predictive, it tries to answer some predictive patterns based on the pattern or data which is observed in the past. So it's a feedback loop. So if at all something, so there is something like something is predicted and something actual happens. Now we actually again feed back the data to the system, so that now the machine is now more robust enough to identify these kind of outliers also, and then predict more better in the future. So that is what ML is all about. And some basic differences between stats and ML, like it is a computer science field, the ML is, and its more focus is about creating systems that learn from data. So it is like the data that you provide as input, it starts to naturally learn from the data, identify patterns, and going forward, whatever the input that you provide, it tries to predict the output. That is what is the purpose. You can see is the prediction accuracy and optimization. Whereas in stats, it's about the inferences that you obtain from the data, which has already happened. But in ML, you will try to get the going forward, what is the prediction? So that is why people in business world or in any domain are more towards this ML and AI. Like what is something which will happen in the future? I want to have some prediction accuracy, like 95% confidence or 90% confidence that these are the events that could occur in the future. So that is what is going. And in a classical machine learning, there are actually two broad categories. So one is called supervised and another one is called unsupervised learning. So as the name suggests, in a supervised learning, what we generally do is, if I have, say, 10 packets of biscuit, I would quote that this packet A is called Britannia, packet B is called Parle G, packet C is called Sunfeast, Marie-Light, and all those. So now I would feed a lot of data to my system, like, okay, these are this one, and I label for each of these. So now what happens, there are a lot of machine learning algorithms which are actually written, so which can interpret all of these data. But all of these algorithms in turn use statistics. So I could say, like, machine learning is nothing but a calculator that you have in your hand. It's a tool that you have in your hand. But unless you know the arithmetic and also I can say 3 into 5 is equal to what is 3 into 5, and my calculator simply returns 15. But how 3 into 5 is equal to 15 is something what stats will give you. So machine learning is nothing but a tool which will interpret the inputs that you give and give you a reasonable output. But the basics behind that is how the arithmetic is basic behind the calculator. Statistics is the basic behind the ML. So coming to here, so what we do is we give all these data, and then in a supervised learning, what it will do is next time you give Britannia marigold, it will say that this is a marigold biscuit because based on the past data that I have supplied. So if I now go ahead and give some other data which is not labeled till now, this will not give you a correct result. So if I give you a bourbon biscuit to that machine, it would say something, some random, say it could say Mary, Sunfeast Mary also, because that data is not feed into the system. So that is what is supervised learning about. But in the unsupervised learning, what it does is it identifies the patterns, it identifies the similarities between each of the inputs that you have given, and it will form different clusters. So I will show that here. So this picture actually very much explains the what supervised and unsupervised learning generally does. So you have ducks and the rabbits and all the other animals. So in supervised learning, what you would do, you will label each of, okay, this is a duck, this is a duck, this is not a duck, this is not a duck, and a predictive model will be built out of this. So what this does is, once the model will have all the algorithms and all the patterns, how a duck should look like. So next time when you actually provide a duck, the model will guess that, yes, it's a duck. If you give a rabbit, it will say it's a rabbit. That is what a supervised learning algorithm does. But what an unsupervised learning algorithm does is, it identifies similarities. As you can see, it has grouped all the 3 ducks into one cluster, the rabbit into another cluster, and the porcupine to another cluster. So all of this is a clustering algorithm. So next time when I give some other duck, it would cluster to the first duck, first cluster saying it is very closely related to the first kind of elements that I have found. So that is what is the basic difference between a supervised and an unsupervised learning. Yeah. Second. So if you have any questions also, you can ping me. Okay. I'll go about a real example here on where ML is being applied. So we all had a lot of emails, and there are many spam emails in a Gmail spam box, the junk folder. No, okay. The output of a supervised model is always a binary, not necessary. But in our case, I have taken only the binary example. There could be a lot of categorical values. So, for example, take a color. So I can have red, green, blue, and based on that, if I have already given some data that these are the colors of textbook or something, and based on that, whether the color of the wrapper of the text is blue or black or green. So based on that, the different kinds of output can also be given by a supervised learning. It's not just a binary output. Okay. Okay. But to start things off, we are taking binary kind of scenarios because it is more easier to understand binary rather than going into a higher dimension output. Okay? So yeah. So here in this, what we do is we all have like thousands of emails as the input. So what we do is we build a classifier model here, ML model, which basically we give the input data. Yes, these are all spam emails, these are all good emails, and these are all spam emails. So all of these data are passed as input to the classifier, and the classifier builds a model which can now identify the what all messages should go to the inbox and what are all spam messages, possible spam messages could go to the spam folder. So next time when a new email comes, it automatically segregates like these are all good emails and it should go to the inbox, and these are all the spam emails because it would have seen a good number of pattern in the past that these are all the spam emails, and then it moves to the spam folder. Suppose in case any of the inbox now comes with a new kind of spam email, you would generally mark in your mail client that is marked as spam or marked as done, so that this feedbacks as input to the classifier, and next time when the same kind of email comes, it moves to the spam folder. Similarly, when something which has to go into inbox is moved to a spam folder, you would move to an inbox, so that this feedback is now also supplied as input to the classifier, so that it now knows that, okay, these kind of emails are now to be treated as a and I'll just move on to the last topic. So the case study, and so there is one question. Okay, I will take the question to the last so that it will be easier. Okay, I'll just finish off my webinar and then go ahead taking the questions. Okay. So here we have a case study. So in finance, where all we usually do like basically in credit card fraud detection. So there are few credit card and debit card fraud detection there. So there are few times our card get compromised in sometimes due to unfortunate incidents. So that time fraudulent transaction versus a genuine transaction. So that is what the real very intuitive and very necessary data what the finance really requires, and we have seen a lot of. So I have personally experienced kind of my credit card has been data has been stolen, and have been used a minute across Brazil, France, and all those. But out of those 4 transactions, 1 transaction only actually got succeeded, and rest of the transactions were actually auto-failed by the fraud detection system. So all these actually continuously span for any anomaly data, whichever when compared with the past. So within a second, a customer cannot swipe between France and Germany and UK or something like that. So these kinds of anomaly patterns are fed into the system using the ML models, and in real time, it just gives you the fraud detection and prevention. Also, the investment predictions done by a lot of many jargons like JP Morley, Bank of America, Morgan Stanley. They all give like the investment predictions for this kind of stock or this kind of investment. What could be? Also, you have some CRISIL ratings like you might have seen AAA stable plus, AA plus, double B minus. All these. So all these gives us a kind of a risk profile that whether you are eligible to give how much risk can you predict, or how much returns that you can expect on all those. Even in credit risk, it is being widely used, which I will talk later. And the algorithmic trading also. So the ML models are like going around like you would backtrack. So what people in algorithmic trading are now doing is they would build lot of rules and lot of that moving averages and all those. So based on that, they create some rules and then they backtrack the algorithm. So like they may backtrack on a particular stock or any particular investment. They would backtrack like around 5 years and 10 years and see how the returns would have been if the stock had been traded on that time period. So if it results a good yield, then going forward, these algorithmic trading. So there are many startups which have been started based on this algorithmic trading. So you can just Google out them. So there are few interesting startups who work basically on this algorithmic trading and gives you, they say they give you better results. But all this algorithmic trading would always have a domain expert. So that domain expert would have fed the data, like how in supervised learning, the domain expert would have fed all the necessary data and created this ML model, so that going forward, it gives a better yield and better results, and it is good for the investor. So that is what is the thing. And for any personal or business loan, there are few things which we take as input. So in any of the personal or business loan that you go to a bank or any financial institutions today, they would do 3 steps. First, they would underwrite your application based on the information that you provide, and then they assess the risk out of that underwriting, and then whether they come up with either to give a loan or to not give a loan, but based on a risk that comes out of this typical process. So what you generally people in finance usually take up is these things like annual income, the expenses that you incur on a monthly basis, the dependents that you have, the existing loans, and also the CIBIL score. There are a lot of parameters that these ML models take. So what they have done is these are all repeatable process. So what in new and fintech domain, what they are doing is all of these information are collaborated, created ML predictive models have been done, and then compared with the previous results. If all of these previous results are good enough, like say a model is predicting enough like 95% or 97%, they would go ahead and build these automated models to make sure that the manual process in going of all of these steps. Because in this world, it's a fast-paced world. People are expecting quicker need of credit. So if I wanted a credit, I wanted like in a day or two. So there are nothing like I don't have to wait in a long time. Like I don't have to wait for a month or 2 weeks or something, because I am in a very quick mode and I wanted cash immediately. That is why I am approaching this financial institution to help me out in this situation. So the financial institution now is move forward into a need. So this digitization has happened a lot into the computer science domain and all these information technology domain, but the finance has been very late into taking into these aspects. But once we have seen like the stock market, which have been made to digital. Earlier we used to trade in the paper trading and all those. So as the time and money evolves, the investment in fintech domain also has been done into this building this ML models based on this. Also, you would have seen something like So the last one, which I would see, like we all invest in mutual funds and all those. So we would see some indicator like moderately high and high, or moderate, something like this. So here we should actually know about this this graph, which says low risk and a low return, but a high risk means a high potential. So based on where you actually do. This kind of models and all these data would give you a kind of result on where this risk associated with this particular investment is associated, and based on that you have to take the decision. So that is why SEBI or any investment portfolio are giving us this kind of information, so that the investor has to take some informed decision. So that is what is the application throughout the fintech domain has been. And yeah, that's it from my side.